Hello, everyone. All right. I think we're going to get started. If anyone has not attempted to clone the repository yet, I recommend doing so now. We're going to start with kind of an introduction. So if you haven't done that yet, you will be able to kind of sit there and listen to me talk and watch it attempt to clone. I did mention earlier, but for those who may not have been here yet, when you do go to the README, the instructions that it has for cloning the repository assumes that you have an SSH key installed. If you don't have an SSH key installed or you don't know what that means, you can also go to the top here, click the clone or download link, make sure that this says clone with HTTPS, and then try to run a git clone on this instead of the other URL that's in the README. That should help solve some problems. All right, so how many people here, this is their first PyCon? Yeah, okay, cool. That's quite a few of you. How many people did a workshop yesterday as well? Okay, so you have like half a brain left after everything you crammed into it yesterday? Cool. So first off, I want to thank everyone who responded to the pre-workshop survey. I got almost 60% of people to respond, which is really, really great. That really helps me kind of cater my materials and the tutorial to all of you who are in the room. So thank you for that. I will note that there were quite a few more people who had very little experience with Python than I anticipated. And so I just want to encourage everyone to not, if you are somebody who's a beginner, try not to get caught up in the details. And if you happen to have problems with your environment or anything like that, I do sort of recommend pairing up with somebody who might be sitting near you who has it running and who can kind of walk you through it. I think that you'll get a lot more out of it if you try to just pair with somebody else instead of like fighting getting a virtual environment running or something like that. So, does everybody have these resources? If not, get them now, or get them from your neighbor. Okay. All right. So a little bit about me. My name is Emily Morehouse. I am the director of engineering at a company called Cuddlesoft. We are a digital product development company based in Denver, Colorado. So I get to kind of Denver. I get to really touch on a lot of different pieces of tech. I help write mobile applications, web applications, backends, CI pipelines, embedded systems, really the whole 9 yards. So this talk is a little bit broader than most tutorials probably will be. It's probably more rare to see such a deep dive on like back-end testing as well as some front-end JavaScript stuff. So I hope that you are all excited about that and that you are along for the ride. I'm also a Python core developer. If you are in the JavaScript world, I help maintain a package called Axios. It's basically like the requests of JavaScript. I'm a huge visual testing proponent. I'm a huge auto format fan, so you'll see that in my editor. And in general, I'm just a really big language nerd. Okay, so this is our schedule that we have set up for today. Like I said, these first 20 minutes are really going to be me kind of talking to you and giving you an overview of the different things that we're going to cover in this talk, as well as the reasons why it's important. Just kind of like lay that foundation so that we can really dive into some code. We will have a quick 20-minute break after that, just to make sure that as many people are up to speed as possible and have their environment set up. Hopefully all those really slow Git clones will be finished by then. And then we'll have about an hour to dive into regression testing in Django. And I'll talk a little bit more about like exactly what to expect for that hour. Then we're going to have a quick break. There will be snacks and coffee and all that stuff out starting at 3 o'clock. Also during that time, if you need additional help setting up, whether for questions on the Django section or for the next section for JavaScript, that's an additional time that we can use to help everybody. And then for the last hour-ish, we'll dive into visual regression testing. Okay. So we're going to start this off with a quick overview of kind of testing. I'm going to talk a little bit about why consistent testing is important and what consistent testing really means. We're going to talk a little bit about software correctness, because in order to test your software, you have to have a good understanding of what you're testing for and what correct software means. Going to go through a few different approaches for software testing, and then we're going to dive into kind of the anatomy of the test, and really like all the different pieces that you're going to be touching, whether you're testing a back end or a front end. Okay. So I think that when you approach testing your software, it's really interesting because the time that you spend writing tests for your software is not time that you're actually delivering features or value directly to your users. So it's a really interesting mindset that you have to get yourself into of understanding why testing is important and why, especially for like the longevity of a project, why it's really important to write solid tests. And specifically why regression tests are important to make sure that all of your future users are not encountering old bugs and that you're not kind of like getting into a cycle where you break one thing and you fix the other thing and that breaks something else and you just kind of get into this cycle of your software not working. So there are a bunch of different types of testing. I'm not going to go through all of these. We don't need to focus on all of them. But if you start thinking about how to test your software, you're going to come up with a bunch of different ways to approach it. And so one of my favorite ways of testing software is using regression testing. So again, really focusing on like known bugs that are coming up, and then visual regression testing, which we'll get into why visual regression testing is really cool in a minute. And so one of the really interesting things is the human brain is really terrible at distinguishing between stimuli. So if you take a look at these two images, they're both screenshots of the PyCon website. And even if you were to look at these full screen, it would be really, really difficult for the human brain to actually detect the differences between these two screenshots. But there is a difference. And so it's a lot better to let a computer kind of handle automatically detecting these changes than to rely on a developer or a QA engineer or somebody actually going through and looking at this themselves. And so one of the huge gotchas with tests is that tests only actually catch bugs when you run your tests and you write tests. And so knowing how to approach testing and how to kind of like pinpoint these different areas where bugs can arise is super important, and can actually be a bit trickier than a lot of people kind of expect. So with that in mind, we know that we need to have tests that are really fast so that we can run them locally. Maybe that's as we're developing, doing test-driven development, before we commit, before we push, before we release to production. All these things, you need to run your tests before that. We want to make sure that we can run them across different browsers and platforms, and that we're not going to take the entire day for a test to run. Because if you have a test suite that takes 20 hours to run in the cloud, you're not going to be able to push out quick releases to your users. And then you'll basically be in a holding pattern for however long your tests have to run before you can, hopefully before you push to production. So we know that our tests also need to be reliable. We need to know that when they're given the same input, that they have the same output. And one of the things that you don't want to get stuck in is just constantly debugging your tests or having tests that break. So it's really important to kind of put a lot of thought into your architecture around that. And thirdly, you want to make sure that your tests are really modular and direct. So in the same way that you want to think about having functions that maybe do like one single thing really, really well in a few lines of code, and then kind of like modularize it out from there, you want to approach your tests in the same way. If you have too many things that a single test is trying to like check, the whole test could fail, and you would not know exactly what line is failing or what's happening there. Okay, so a lot of this I like to borrow from something called formal verification. I see a lot of parallels between formal verification and software testing because the ultimate goals of both are to make sure that your software is correct and that your system is fault tolerant and stable. And so one of the pillars of formal verification is that no software is inherently correct. And so there are two different ways that we know software is correct. And I pulled this quote from a Medium article by somebody named Andrew Helver. So these are not my words, but I really kind of identified with it. So one of the ways that we know that software is correct is that the supreme deity of the universe descends from the heavens and decrees with all of the weight of objective truth that a certain piece of software is correct. But in reality, what happens a lot more frequently is that we'll have a list of things that we want the software to do and a certain amount of logic to prove that the software does these things. And as our software grows, this list gets longer and longer and longer, and it gets a lot harder to keep track of exactly what our software is supposed to do and what having correct software actually even means. So now in the first scenario, as silly as it is, we're talking about objective truths. We're talking about things that are not going to be debated. This sort of all-knowing, powerful knowledge that everything that has been and everything that will be known is right is not something that we actually get in software. And so functionality of our software can be subjective, it can be very ill-defined, and it can certainly be relative. So, different approaches for testing. So when you start to approach testing, it's really common to come at it from one of two ways. The first way is that we can say, how do I know that this software is correct? Or, how can I break this? So this gets kind of fun. So the first way, when you have something that's really, really well defined, you can take that logic and kind of put it forth into a test. So we know if we needed to test, say, multiplication, we know that we have a very finite set of input, whether that's a positive number, 0, a negative number, and how that can interact with the same input multiplied together. So we can say, I know that when I have 2 times 2, that it's going to be 4. When I have 2 times 3, it's going to be 6. And we kind of have these very discrete set of rules that we can apply. But in this case, all of our edge cases are sort of defined for us, which is one of the really fun things about testing, and one of the reasons why it's really important, is that you have to really start diving into what those edge cases are, and especially when you start testing front ends. It's what happens if a user mashes on the submit button? Those are not things that you necessarily think about, but it's things that automated testing can help you with. So a lot of what I've been saying right now is kind of talking about software testing in theory versus reality. So in theory, you can have 100% test coverage, and all of your tests are going to catch every single bug that possibly exists in your code. But the reality is that that's not going to be the case. And even if you have 100% test coverage on paper, doesn't actually mean that you're necessarily catching all of the issues that could come out of your code. And so as an engineer, kind of going back to this idea that the time that you spend writing tests is not delivering direct value to your customers or your clients or whoever it is, I know that the more time that I can spend writing really useful pointed tests is going to be a lot better than just kind of arbitrarily writing tests for the sake of writing tests. So one of the ways that I've tried to kind of optimize for this is a theory that's kind of popular in a lot of software design, and that's that I really try to approach everything from the user's perspective, because the user doesn't care if an API endpoint is broken. They just care if they can't log into your app, kind of thing. So once we start kind of framing what is important for the end user, we can also frame how we approach testing. And so regression tests, and especially the visual regression tests, really kind of frame that for the user. And it gives us the ability to say, okay, here's my application. if I don't directly test my authentication endpoints, etc., if I just test my login page and I know that my login page is failing and the user sees an error that says error could not, I wouldn't put this as a direct user facing message, but like if there's some sort of error that says like cannot connect to the server, like login failed, and you know that the user's like credentials are correct, you can then pinpoint that like, oh, there's something else going on that is affecting my user, and give you a better idea from a really high level of what's broken in your application without having to write a million different integration tests across your stack. Okay, so I'm going to dive a little bit into the anatomy of the test. I think I'm doing okay on time. We're just a minute off. So the anatomy of a test, you need to have a test environment. You need to have a testing structure. You need to have some sort of assertion library to be able to say like, if these certain set of requirements are met, then the test passes. Otherwise, the test fails. Some other really helpful things to have are mocks, spies, and stubs. So if you want to take different parts of your application and abstract them away, so say you do want to test an API call, but it's also relying on a third-party API, you might want to mock out that third-party API so that you're not necessarily relying on an external service's success, that you're only relying on your code's success. And then, especially once you get into like the front-end testing world, you need some sort of browser or browser-like environment. Okay, so the process of testing consists of basically 3 major steps. So the first is that you want to generate, display, and watch your test results. So kind of as you're running your test, it's going to tell you exactly which test it's running through. You can see the success and failure as you go. Maybe if you realize that like your first 10 tests are failing, you just kill the process and try to figure out what's going on instead of just letting the whole process run. As those tests are running, each test that you're running through will compare and check different assertions. And we'll get into exactly what that means in a minute. And then at the end, you want to generate code coverage reports and really be able to see which areas of your application you are testing and like the success and failures in those different areas. Okay. So we're getting close to our first break, where we're going to make sure that everyone is as set up as possible. I do want to go through a little bit of how the workshop is going to kind of work. So there is example code in the repository. And so let me actually pull this up. Okay. So there's a section in the README about how you can use this repository. And so basically the way this is set up is that there are 2 separate branches. There's one for our Django walkthrough, and there's one for our visual test walkthrough. If you check out to the branch, you'll be at the end of the tutorial. So if you want to skip ahead and miss all the fun parts of like learning and exploring along the way, that's what will happen if you check out the branch directly. But if we take a look at this branch, basically all of the commits are kind of separated out by step. So any of these commits where you see a number in them, that corresponds back to the class notes, which I'll show you in a second. And so each branch also has a tag. And so the tag is like the very first commit of that walkthrough. So there's a visual init and a Django init. So if you want to kind of walk through on your own, that's where you'll want to check out. And then in here, you can click directly to the steps, or there's also steps here in the content and notes. So for example, for regression testing in Django, if I click into this, this takes me to the README, which has a list of all the steps. And then as you go through here, you can kind of follow along. These are the steps that will correspond to the the code that we're going through, and then everything links together at the bottom between steps. And so I know that I have a pretty wide variety of skill levels in the room. And so there are a few ways that you can approach this. I am going to go through and explain everything. I'm going to walk through all these steps. I'm going to code it on my machine. I'm going to demo it. I'm going to explain it, all that stuff. After I do that, it's then up to you in terms of like how you want to use your time. You could check out from the initial, like the Django init tag and code everything yourself as well. You could pick a certain commit and go off in your own direction if you're like, I really want to dive into like more of how this specific thing would work. Or your other option is that you can actually like just check out commit by commit and run it on your machine locally, and not necessarily code everything yourself, but just check out the commits and see it running on your machine. And then really just kind of like dive into the differences in the code that was written by looking at the commits. And to do that, I would say, for anybody who's not as familiar with GitHub, there are some instructions about checking out different commits in the README, but you can also go in here and click on the commit ID, and then it will show you a diff of the previous code that was there. In this case, there wasn't any other code here, and then the new code that was added for these steps. So hopefully that gives everybody a lot of options that you can kind of choose your own adventure on. And at this point, we have a few TAs that can kind of help get people set up. Yeah, just let us know if you need any help. Just to be super clear, the only section that we're worried about right now is getting started and installing dependencies for a Django application. So if you haven't done that, check out Sub-Zero, follow these instructions, make sure you can get your virtual environment set up, and then hopefully once you get that set up, you can run these 3 commands to kind of get everything kicked off. All right. So I think it's probably about time to call it on attempting to get environment set up, because I want to make sure that we're using the rest of our time for at least me to kind of go through and work through all of this with everyone. I'm going to go through everything now, so I think this is going to be a lot of kind of like watching me do things. But at the end of this, if you haven't gotten your environment set up, it really is your call if you want to try to keep working on that. But otherwise, I suggest that you find a friendly face that you might be sitting next to who perhaps has this running, that you can kind of work through it all with them once we get to that point. Cool. Any questions before we dive in? Okay. All right. So I have just run through all of the same initialization on my machine. So I've run the migrate, the create super user. I'm now running the server. Well, I'm not running the server. That's a lie. I'm now running the server. If you go to that URL, you should then see this kind of like example regression testing boilerplate. If you see this, everything is working correctly. We're not actually going to do a whole lot of interacting directly with the front end of this application. We're going to kind of go through how we're approaching testing different pieces of our Django application. Let's see. So right off the bat, if we run Python manage PyTest, you will see that there are currently not any tests in this repository. It's not finding anything. So the first thing that we're going to do is kind of start diving into adding a test case. Hopefully this is large enough for everyone. I think if I make it too much larger, it kind of doesn't fit on my screen. So if you need to follow along with the repository on your local machine, you can do that too. All right, so first we're going to create a new file. So let's see. So I have my editor open to the source directory. So you can see that here. So the tree that you're seeing of all of our code is actually like within that source directory already. All right. So inside of our regression testing boilerplates, we are going to add a file called test.py. Let's see. So the first thing that we're going to go through and test is something fairly straightforward. We're going to test that the page is actually just rendering. So when we go to this view, that we are able to retrieve the file from the index of our website, and that we are getting a 200, and that this page renders. So to do so, we are going to grab, not that. I don't have 2 minutes right now, VS Code, sorry. So we're going to say, let's grab, there's a sort of base test case that we can grab. And as everyone knows, typing in front of 50 people is when you make the most typos, so that's fun. So we're going to grab our base test case. We're also going to go ahead and grab something called reverse, that's basically going to let us retrieve the view based on the name of the view. So what we're seeing here in our Django application, this page is called home. So we can basically pass home to reverse and get the URL for it. Okay, so let's make our first test. Again, we're just testing that the page is opening. So I'm going to naively call this the page open test case. We are going to extend from the base class test case, which is going to give us a lot of like mix-ins. It's going to give us a lot of those like assertions that we talked about earlier. That's all going to be baked into this test case. So within this, we can now start defining basically different methods on this test case that will represent different isolated functions that are going to be called against our class. So these are the places that I mentioned earlier that like we want to make sure that these stay pretty small, because when one of these tests fails, it will say like, hey, function 1 failed, and sure, it will point you to like an exact line, but if you're testing too much in one of those tests, it's gonna get really confusing to try to actually pinpoint any of your errors. All right, so we first want to make sure that I would say that our home page exists. So we're going to make sure that this page can be rendered. So we'll make our function for that. Again, we're going to retrieve our URL from reverse. Like I mentioned, this page is called home. I know that there are some people here who aren't necessarily fluent with Django. I unfortunately don't have a whole lot of time to dive into that and like where exactly all this is set up. If that's something you want to learn more about, come find me afterwards or during one of the breaks, and I can show you all that. All right, so the next thing we're going to do is actually test to make sure that we can make a call to this URL. And so baked into this test case, we have something called the client, so we can run a get on our client using the URL that we just retrieved. So we've gotten the URL based on the name of this page that we have set up, and then we call a get to that URL to make sure that we have all this information. And so at this point, I'm just going to run this test, and my auto formatter is going to change everything I just typed. So I'm going to run this test and see what actually we're getting back from R. I'm actually also going to, that's probably just going to print out an object, so I'm going to also run dir on R so that we can see all of the different methods that we can get from it. Cool, okay, so now we've just run this test. We have a response object that we have retrieved back from calling this URL. We can already see that our status code is 200, which is good, 200 okay. That means that the page is rendering, everything is going normally. And then if we look at the dir of this object, we can see that we have a bunch of things that we can call on it. And so this is where it gets really interesting that you can kind of dive into more specifics of this request. But for right now, basically what we want to make sure is that when this page renders, we get a 200 OK. So now if we come back here, I'm going to take out my print statements. And at this point, we can run an assert. So again, baked into our test case class, we now have something called, I'm going to use assert equal. And I want to make sure that the status code that we have retrieved is equal to 200. Hopefully I typed all that right. Hey. All right, so it ran one test, and everything is successful. So one of the things that you'll also notice that you kind of get out of the box when you run this test is that it's already kind of baked into Django, that it's going to create a test database, and then it's going to destroy that test database for you. So that's just kind of one of the niceties that you get, batteries included with Django. All right, so let's see what else we have on this page. Not a whole lot going on in this application quite yet. So we have our home page, and then we have our about page, which apparently we don't have. So let's practice a little bit of test-driven development here. So let's say that we know that we want to add an about page. So we're going to write our test, and actually I'm going to do myself a favor. I'm going to copy this code, because we're going to do basically the same thing for our about page as we did for our home page. So now basically all I've done is I've added a new method to our page open test case. And I now have a method to test that the home page exists and that the about page exists. So now if I run this, interesting. So it's not actually telling us anything at this point, right? So we're running this. It's saying that it ran 2 tests, but we know that this test case should be failing, which is sort of interesting. Let's see. I'm actually curious. So this whole thing is a lie, because that's the joy of live demos and coding in front of people. So the reason why that about page didn't work before is because my server wasn't running. So that's fun. So if I go back to this page, we can actually see that the about page does exist, and that's why all my tests were still passing. So now that's not what I want. So now if I go back, I'm going to kill my server. And if we go back to our code, we now know that our about page does exist already. We're going to do the same thing for a new page that doesn't actually exist. So I'm going to do this for our contact page. And then hopefully we can actually see a test that properly fails. Hey, OK. So we can now see that we have a failing test, which is what I was going for. So we get this nice traceback. It tells us exactly which method failed. So again, like that's helping us pinpoint what's going wrong. And then we can see that we are getting an error that says no contact found. Contact is not a valid view or pattern name. So I do kind of want to pull over to the README real quick, because I wanted to kind of point out a few different things that we have kind of read out of the bat, or like right out of the gate for our test case. So there are a few different built-in test cases, depending on exactly what you're trying to test. So there's a simple test case, a transaction test case if you're specifically dealing with database transactions, live server test case. There's a bunch of different ones that you kind of have built in. So I definitely recommend kind of exploring and figuring out what efficiencies you can gain from using the built-in tests. But I also wanted to point out some of some of the main asserts that we have that basically come from unit tests that are built in. So asserting equal, not equal, true, false. It's really important to kind of rely on these built-in assertions to make sure that you're properly tying into your test runner, and making sure that you're not relying on the actual like Python assert statement, because there are some weird things that happen if you use the Python assert statement and not one of these built-in functions. So these are just a few examples of what you can kind of like rely on that's built in. Cool. All right, so now we have a nice failing test. So our goal here is going to be that we can actually fix this test case and get this test to work. So now we know that we have these two pages. We need to add a contact page. So the first thing that we're going to wind up doing is adding a URL path to our URL patterns. That's usually where I start when I go to add a new page. So we can put this anywhere in this array, but we're going to add a path for contact. Just kind of as a practice, I like having the slash at the end of all of my URLs, just to keep things consistent. And then we're going to do something similar to this, so I'll just copy it and paste it. So we are going to want to create a contact page, and this is where we set that name that we use for the reverse function. Cool. I think this looks good. I don't think I've misspelled anything or typed it wrong yet. All right, so next thing that we're going to want to do is actually create this contact page. So if we go to our views, I'm just going to put it in this like high-level views. You can see here that we already have our home page and our about page. For a lot of Django applications, you're going to wind up splitting these out. But for this example, we kind of have everything in one place just to make it a little bit easier to deal with. So we are going to create our contact page class. Not that. So we're going to do the same thing that these other ones are doing. We're going to create a template view and then give it the template name. We're going to make this a contact page. So basically what we've done so far is we have created the URL for it. We've pointed it to a view. Now we've created our view, and we need to actually provide the HTML content for this page. So if we go back and look in my very small sidebar, we can take a look at this templates directory, and we can see that we already have a few other HTML pages in here. So we're going to add our contact.html page. And this one I actually am going to just kind of copy paste in. The actual code that goes here does not necessarily matter at this point. We just know that this is going to be a page that is going to render something that we have just given it. So if we go back here, I think that everything is set up correctly. So even before having to run my server, I was able to run my tests and see that I'm now getting back a 200 from this page. Just to make sure that we know what is going on and know that I can still type the word run server. We can now go back here. I haven't actually added a link to get to the contact page, but I can go here and go to my contact page, which is not rendering. So this is a pretty common approach for testing your views. Certain things that view testing is really important for is making sure that people have proper permissions to view pages. So if you have an admin portal or certain pages that are only controlled by somebody who is a super admin or admin of a site, it's important to make sure that those pages remain protected. So doing things like testing as an unauthenticated user that I get either a 404 or a 401 response from those pages. That's a really common way to use these view tests. Does anybody have any questions? Cool. All right, so I'm going to close out all of my files that I was using there. Collapse that back up. So the next section that we are going to focus on testing is testing models. So if you're following along, this is step 2. Yeah. All right, so now we can set up an example model test. So let's go ahead and dive into some of the existing models. So if we check out here, I can't make that any smaller. So if we look at this, this is our profile models page. We have a base profile that we're setting up. Again, we kind of have these like built-in classes that we're pulling in from Django itself that are letting us kind of scaffold out a lot of this code. So we have a basic user model. We have a slug that's going to allow us to get the user's profile like page URL. The user's going to have a picture, a bio, and we're going to make sure that the user's email is verified before they are able to sign in. And so we're going to default that to false. I think that is pretty much the important things in here. So let's write some tests for our user model. Let's see. So we already have our page open test case. Let's actually keep this a little bit more modular. So because we're writing tests specifically for our profile module and not for the application in general, we can actually go ahead and use our test file that is inside of our profile module. So I know it's a little bit hard to see because the screen is a little bit small, but this test file is inside of the profiles directory. All right. So some of the things that I like to test for this is just making sure that you can create objects for different models. And again, we have a few things from Django that we're going to kind of build off of. So if we go back here and look at, actually it isn't mentioned there. That's a lie. So somewhere along the lines, this is like registered as our user model. So that is actually something that we can kind of tie into. So I'm going to grab our get user model. There we go. That's the joys of linting, folks. I'm also going to import our model itself. This is way harder than I expected it to be. Okay. And then basically we can say we're going to set our user model to this. So this is one of the helpful things about these little pop-ups that keep getting in our way. So get user model is going to return the user model that is actively set up for this project. Cool. Okay, that is all looking pretty good. So now we're going to set up some test cases for our user model. So I'm just going to call this user test case. As your application grows, you'll figure out different kind of naming conventions that you want to use. A lot of times things will start out maybe a little bit more generic, and you'll kind of increase the specificity of the names of all of your classes and methods and whatnot. So what we're going to do here is we're going to start tying into some of like the lifecycle methods of a test case. So one of the things that you can do is you can have a setup command. So if you want to kind of like create different resources to use while running your tests, you can do that in this setup command. And that will automatically take precedence over all of your other tests that are going to run. So basically it will go through and say, do I have a setup function? Do I need to create any objects? Yes, this has a setup function. I'm going to create whatever it's asking me to, and then that resource will kind of be available in the rest of your test methods that you're running. Okay, so let's say I want to, I'm going to use get or create, just in case this user has already been created. Okay, so now in my setup command, I am getting or creating this user object, and then I want to just test to make sure that we have different attributes that are defined on this user model. So I'm going to say we're going to test our base profile because that is what we are, that is the model that we have set up as our user model. It is possible to have like a bunch of different user models, so you might have one that's different for admins or different like user hierarchies of your app. So I like to be really specific about which user I'm testing. Okay, so now I'm going to test that our base profile can be created. So in here, since we already have this set up, all I have to do is actually retrieve that object. So I'm going to say user.objects.get. It's going to be the same email so that I retrieve that user. And then again, let's just see, make sure that we have all the things that we want to have. So I'm going to print out our object, then I'm going to print out a dir of that object. So now if we go through and run our tests, cool, I have 4 tests that are running. You'll notice that this test is not yet failing because we don't have any asserts in it. We're just able to kind of like run it and print stuff out and kind of see what we've got. So I'm going to kind of pick out just a couple of things that I think might be important on our user model. One of the things that's always super important for a user model to have is an ID. So we want to make sure that that exists. We also want to make sure maybe that when we create an object that the values that we're providing to create that object are getting set properly on it. So because this is a pretty simple example right now, the only thing that we're setting on the user object is its email. And so that might be one thing that we want to make sure that the email gets set properly as we're like asking it to set the email. All right, so we've seen what that user object looks like. So let's just say, we want to assert that the user has an ID. We want to assert that the email address that we have provided and the email address of the created object are the same. So I'm going to say that is equal to u.email. And really you can kind of go through and if you look back at the user model, I would definitely try to make sure that like all of these things exist. One of the things that I might do is assert that when I create the user object that that the email verified setting is set to false, because that's really important. Maybe it's part of our business logic that like a user has to click a link in an email to make sure that they're using a valid email address first. So this is something that's probably important to make sure gets set correctly. So now, hopefully, oh, this is why you're at tests. So we want is not none. We definitely want them to have a user ID. So let's see. So user doesn't have an attribute email verified. So let me look back at what this object actually looks like. Yeah. Huh. Well, I'm not going to dwell on this necessarily because I don't want to debug why this isn't working at this moment. But just know that like that's definitely just something else that you can kind of like keep an eye out for, and making sure that you're testing all these different pieces. Yeah, because I think I only have about, according to schedule, I only have about 15 minutes left for this section, so I'm going to keep trucking. All right. So going back to a little bit more kind of like in-depth on testing our views, sometimes it's going to be important to test more than just the status code that we received. Sometimes we're going to want to make sure that different elements are appearing on the page, that there is a link to get to the sign-up page, that kind of stuff. And so we have a little bit more information from those views that is sometimes helpful to kind of dive into. Let's see. So if we go back here and look at what else we can get from our response objects. So let's just look at the dir of R again and see what else we have here. Hopefully I put everything back and everything's passing. Okay. So as we kind of dive into this, one of the things that can be super important to look at is content, which is split between two lines. So just out of curiosity, let's see, not caps lock, let's see exactly what this looks like. Ooh, yeah, so this is cool. We actually get all of the HTML that is going to render on the page. And something that gets important when you're looking at making sure that your view code is working is you can make sure that, say you have different variables that are getting rendered in your template, you can make sure that those variables are getting interpolated and like either calculated or retrieved correctly. So for example, I'm not going to dive into this right now, but one of the things I would say to test is like, say you have a user profile page that displays their name and their email address on it. I would make sure that I'm retrieving the user model correctly and that those values are getting displayed properly by like asserting that the first name gets displayed in the page and is actually present where I expect it to be within all of this HTML. So again, you can kind of like dive really, really deeply into exactly what parts of this you want to test. But some of the really simple ways to approach it is just to make sure that a string exists in that content. So let's just say, let's see, this is going to differ a little bit from the notes, but just kind of going along with following those best practices in terms of making sure that our tests are really kind of like modular and atomic. I'm going to add a new method to say test homepage title. I think it's the title on this page. Cool. All right, so I can kind of do the same thing, and again, I would suggest like always taking a look at your code and figuring out what you can move into a helper module. If you have noticed a bit, this is going to get really redundant really, really quickly. So perhaps you have a method that like gets your response for you, and you just pass it the name kind of thing. But yeah, again, see what kinds of patterns kind of emerge as you're writing your own tests to kind of find out how you can optimize this for yourself. So now we can basically just say, an interesting one is assert in. And so you can use assert in HTML, which gives you some other kind of like helper methods for actually like targeting different pieces of HTML based on different selectors and whatnot, which we won't dive into right now. But we can basically say, I want to make sure that the word home appears on my homepage, so the user knows that they are on the homepage. And hopefully this works. Cool. And so, again, not going to do it now, but I would encourage you to kind of like figure out exactly what exists on these pages that you want to dive into. Let's see. How many more steps do I have? I want to make sure that we try to stick to time as much as possible. So we've got a little bit more on views and forms left. Okay. So I am going to skip over 3B, but I'm going to point it out here really quickly. So 3B, we were basically going to like walk through adding a variable that gets computed and then rendered into our template. So if we were to go into, say, our contact page, we can add a way to kind of set this variable within our context that will be rendered on our page. This was just a simple example, so I just set it to 2 + 2 very arbitrarily, so I could show that this was being interpolated. So this gets calculated, it gets set into this 2 + 2 variable, and then inside of our template we can then go through and actually render this as a template variable. So that's what these kind of curly braces mean, is that this is actually interpolated as a variable. And then we can go back through and edit our test. I think in this example I replaced contact with 2 + 2, but yeah, basically this section was going to be just testing that that variable gets interpolated and then exists inside of our content. But yeah, we're going to skip ahead. Okay, so next up is testing forms. So this is one that gets, I think, a little bit more complex, because this is where we get to deal with user input. And users like to break things and do things that we don't expect them to. So this is definitely one of the other areas that I like focusing on, different inputs that I wouldn't necessarily expect to be rendered. And we'll talk a little bit more about how you can approach automating that as well. All right, let's see. So I'm trying to see, do we have a user form? We do have a user form, cool. I don't know why my linter is sad right now. Hopefully all of these things are going to be okay. All right, so if we already have our user form that was already set up for us, we're going to do something similar where we want to make sure that our data gets properly filled into our form. So say, for example, going back to that user profile page idea, if we have a user object and they can say go in there and like change their information, edit their email, password, well maybe not password in this, but bio, anything that they would necessarily want to change. The thing that we're going to test for is making sure that our existing user model gets filled into our form properly. So we have this form here already. I'm going to keep this file open. I'm going to go back to our profile tests. Again, as your application grows, you might separate these out into like a models test and a views test and a forms test. That's a pretty common like pattern that you'll see. But for right now, I'm actually just going to go ahead and extend off of this user test case, because our application is still pretty small. So I'm going to test that our form is valid. So I'll call this test valid user form. Kind of similar to what we did before, we are going to want to retrieve our user object. But at this point, I'm actually going to go ahead and create a new object that has maybe a little bit more information set on it. So I'm actually going to copy and paste this for time. Okay, so I'm going to create a user object for Leia. I'm going to set up a data object. So I'm going to say my name is set to my user's name. And then I'm going to create my form, which I think I will have to add an import for that. I'll have to double check. So I'm going to say user form, and I'm going to pass it my data object. Let's make sure. This is probably going to fail. So I'm going to say from forms import that should work. I don't know why it was sad about it. And again, I'm just going to make sure that all of this is working before I get too far off. Create takes one positional argument, but two are given. Huh. Oh, that's because I didn't. There we go. Okay. So now we can see here that we actually have our form that is rendering. If we take a look at this form, it's a fairly straightforward form. All it has set up right now is a name field. So you can start to see some of the things that Django gives you out of the box as well. So we have this label for ID name. We have an input field with name. Value is set to Leia. Max length, required ID. All those things are kind of already set on there for us. So the thing that we're going to test for right now is just making sure that this form is valid. So if we look at this form, the things that are required on it are just the name. And so since we've pulled out our user object, initialized our form with this data, we just basically want to say that the form is valid and that it has a name set. So there are a couple of ways that you could go about this. You could test directly that the name is set, but what I'm really worried about is that the form is valid and that the user will be able to like submit a change. So I'm gonna add, basically just using this helper method, calling from the form directly to say that it's valid and that that is true. And I'll clean up after myself. Cool. So this test is passing. All right, let's see where I'm at. So other things that we want to make sure that we test are the things that users can break. And so if we're setting requirements for a user, we want to make sure that those requirements are actually being enforced. And again, I'm just trying to be cognizant of time because I know we still have a lot of stuff for the actual visual testing part. But this is one of those places where it's really important to kind of like dive in and identify your edge cases. So say that you have a user bio and the user bio has a length requirement of 200 characters. I would kind of test those boundaries around the edge cases. So like testing with 199 characters, with 200 characters, with 201 characters, and making sure that I'm kind of like getting the errors that I want on either end of it. And then I also like to go for like extremes. So like if somebody put in like 10,000 characters, just to make sure that like there's not some sort of weird bug where it's like, oh, well, we made sure that it was less than 300 characters and we rejected, 201 to 300 characters, but somehow somebody can put in like 10,000 characters. So those are kind of like the fun pieces that you'll see that you can dive into. I'm gonna skip coding out that part because of time. I think I have a broken link in my, I have a broken link in the notes, by the way. Testing forms, I think, refers back to itself and doesn't let you continue. All right. So one of the things that I did want to kind of leave you with for the Django testing section specifically is a bunch of different testing tools. So I highly recommend checking all these out, especially if you're using Django specifically. Django web test is really, really helpful. Factory Boy is really helpful. You can have fixtures that basically allow you to like generate a bunch of different objects for your tests. So instead of having to go through and like create a bunch of objects and like having a bunch of stuff like hard-coded into your tests and like a bunch of data objects hard-coded into your tests, this is really helpful with like spinning up a bunch of different objects. I'm a huge fan of PyTest, so everything so far has been using the built-in unit test, which Django ships with and works like out of the box. I think I had a couple of people on the survey say that they were really interested in PyTest specifically, as well as PyTest as like standalone. I'm a huge fan. Definitely talk to me about that later if you're interested, and check it out if you're trying to write tests for Django. And then one of my favorite libraries is called Hypothesis. And basically it allows you to like write parameterized tests and generate a bunch of different information to really kind of like ease the difficulty of creating test data. So in this example of like testing the user bio, sure, I could probably come up with a bio or find like a lorem ipsum that I could copy and paste and use as like my like 200 character bio or my 10,000 character bio. But you can actually tell Hypothesis to generate these things for you. So Hypothesis will be able to generate like names and addresses and data that looks realistic, but is not necessarily something that you have to hard code. And one of the other really, really cool things about this too is that by using a library that's kind of randomly generating data for your tests that you're running, you can also sometimes find super weird edge cases. So I have a story about that, but I'm not going to go into it now. If anybody's really interested in a really weird bug that broke a car radio in Mazda 6s, come talk to me. But yeah, so it's kind of a cool way to be able to test a bunch of different input, test different address links and name links and different character encodings and stuff that you wouldn't necessarily think to test, and it kind of handles it all for you. And so I think I tried to touch on kind of pointing out a lot of these best practices as we were going through it. But again, modularizing your tests is super important. Being able to kind of pinpoint which areas that you're testing is also really important. Running your tests is probably one of the most important parts, because if you write tests and you don't run them, one of the things I see a lot is that people write tests, nobody runs them, somebody tries to run them at some point a month down the road and they're all broken, and then nobody wants to fix the broken tests, and then you don't write tests anymore. So running your tests is important. If you can have a continuous integration server set up, we'll dive into a little bit more of what that looks like at the end. But continuous integration is kind of the best way to do it, because you can run it on a server, somebody else's machine, you're not worried about configuration, everything is running in the same environment, and it can kind of run without everybody thinking about it. And you can enforce that for pull requests or merge requests, and actually make sure that your tests are passing before merging code together, or before pushing code out to production. I also highly recommend checking out like using local Git hooks. So there are ways to basically tell Git to run certain commands before allowing a user to either commit to a certain branch or push to a remote repository. It just makes sure that all your tests are passing locally before you go and push it off to somebody else. And so one of the things you'll see oftentimes is like, sure, you should make sure that your tests are passing on your machine, but then once you push to a continuous integration server, it's going to run on like a bunch of different machines, especially with front-end tests, making sure that you're testing cross-browser and all that stuff. That's something that's really nice to automate and kind of like let CI handle. And then, of course, like set meaningful benchmarks. Having 100% code coverage does not mean that your software is bug-free. And so really just being able to like focus on the really important parts of your code is definitely important. And then find a standard and stick to it. Be willing to iterate, find the things that are going to work best for your team and for yourself, because making testing a more positive experience is going to encourage you and your teammates to write tests. So if everybody hates writing tests or thinks that certain things are like have too much boilerplate or are really difficult, nobody's going to want to actually write the test. So, all right, at this point we are just a couple of minutes over, which is good. So we're going to have a break. We'll resume around 3:30. So feel free, go grab coffee, snacks, water. If you have anything remaining for phase 2 for the visual regression testing that you want to set up, you can use this time to do so. If you want to dive into some of the Django stuff on your own, again, this is kind of your time to use until 3:30. All right. I think we are ready to get started. Okay, so this is going to be like a huge gear shift change. This is something completely different than we were doing 30 minutes ago, which is part of the fun. Okay, so what I have going here is I have my, this bottom terminal, I was running yarn start. This is basically starting up my web application. I can go to this URL and it will open in the wrong window. And this is just a really silly example React application. One of the really important takeaways from this is that this approach for testing is meant to be like really, really, really agnostic. You do not have to be using React. You do not have to be using any sort of JavaScript framework. You can apply the same like mentality for testing and same testing practices to a Django front end or whatever. Like it could be a static site. Like it really doesn't matter what you're testing. It's very, very, very agnostic. But in this example, we just have a React application because that was a little bit easier for me to throw together. And let's see, what else do we have here? So I've run all of my dependency installation. Everything is set up. I can now run a couple of things. So I can run generate golden, which will now work. An important thing to note is that you do have to have your server running in order to run this. Basically, we'll dive into exactly what's going on here, but there are calls in the generate golden screenshots and the testing that will actually like call your web server. So typically you'll be testing against something that's already deployed or that's kind of already running. But when I'm testing locally right now, I do have to have both of these processes running. So I was just kind of running a sanity check here, making sure that my generate golden was running. And then if I run yarn test, that should also work. Okay, cool. Was kind of holding my breath there for a second. Okay, so let's see. I'm actually going to switch back. I have a little bit more left in the slides that I want to kind of go over first as well. So there are a bunch of different ways to approach visual regression testing. If you have done anything in the JavaScript world, especially with testing, you probably will have heard of something called snapshot testing. Now, snapshot testing is really interesting. So if you remember when we were going through our Django application, how we basically were able to render a page and get back the like actual rendered HTML that the browser had, like with all of our template variables interpolated. You can do something similar in the JavaScript world where you can tell it to give you a snapshot, and the snapshot is going to be a code representation of what that page looks like. But again, as you saw when we printed out that big, long, like HTML content, there's not really a whole, it's not as easy for a human to go through and look at that and say like, yeah, my snapshot is fine, like everything looks good. There's a lot more that you have to put into it manually when you're doing those things. So being able to identify different areas of the page that you want to have rendered, you're really missing out a lot of like the visual side of things. So you can take a snapshot and re-render it, which we'll also talk about later. But actually being able to go in and have a screenshot that humans can look at and make sure that everything looks good is really important. Okay, so the way that we're going to dive into this is when you approach testing, a lot of times you'll have a set of data or information that you know is correct or that should be correct. And so whether that is screenshots or snapshots or pieces of data, whatever it is, we kind of had this idea of what I like to call golden images. So our golden images can be anything from mock-ups that maybe a designer has provided to us and we're trying to match as closely as possible. Or it can be previous screenshots of the application when everything was kind of in like an approved, like solid testable state. So we'll have golden images and then our kind of current screenshots of the application that we'll be using. We're also going to use an image diffing library. There is a really neat tool called resemble.js that basically allows you to take two images and generate a bunch of different information on them, including like a percent match between the two images. And then it will actually also give you back a rendered image of the two overlaid with highlighted areas of where they're different. And so this is going to be one of the really key components that we use and that's really specific for screenshot testing that allows us to kind of do this. Okay. So running visual regression tests really relies on having a browser or a browser-like environment. And so previously, visual regression testing was tied to using an actual browser, using something like Selenium or Phantom.js. There are now really interesting things called headless browsers that you don't actually need like an interface to interact with it. It's basically like interacting with a web browser over strictly an API and not an interface, which is kind of an interesting thing to kind of wrap your head around. I didn't do that on purpose. Okay. But yeah, so it makes it really, really easy to programmatically interact with it. It is also not 2018, which is kind of funny. Since 2018, visual regression testing got a lot easier. There is a library called Puppeteer. It is maintained by Google, but it makes interacting with headless Chrome really, really, really easy. So if you start looking into different techniques for visual regression testing, I really highly recommend just like sticking with Puppeteer and headless Chrome and really just saving yourself like the pain and suffering of dealing with stuff like Selenium and Phantom.js. There's also a lot of like built-in abilities to interact with the browser as well as to interact with your code. So a lot of the same tools that you have as a developer using like the in-browser developer tools to debug your code, you also have access to those things in Puppeteer. Okay. So now we're going to switch over to kind of like the details of how we're actually approaching this. So like I mentioned, we're going to use Puppeteer. We're going to use resemble.js, which is our visual image comparison. And then we're going to use a test runner and assertion library. This is really up to you with whatever you want to use. In this, we're using Jest and Enzyme, but it's really whatever you're most comfortable with or whatever you want to dive in and learn. Those are very like up to you. So those are like our key dependencies. In the package JSON in your example project, there's a bunch of other stuff for like the boilerplate itself. But these are really like the key players for the agnostic part of our testing. And so what I've done here is I've basically taken the important parts of the code and put them into the slides just because I think that based on the survey that I got, a lot of people were a lot less familiar with JavaScript. And so I wanted to be able to kind of highlight these things individually before like throwing everybody into code and moving too quickly through that. So the first thing that we have to do is create our directories. So we basically are going to have a golden directory where we store all of our golden screenshots, a screenshot directory where we store like all the live versions of whatever test run that we're going through. And then a separate directory where we will output those visual diffs of the two images overlaid with the like highlighted differences. Okay, so once we start our tests, the same way that we kind of had this idea of a setup function in our Django tests, we have a similar kind of concept in our JavaScript tests. So we can say either before all or before each test, we want to kind of set up whatever environments or dependencies that we want to use. So for this, we're going to basically launch a new web browser using puppeteer.launch, and then we will create a new page just using browser.newpage. And so again, if you've worked with other like browser emulators and libraries, this is often a lot more difficult. The API for Puppeteer is really, really, really clean. So this is all you've got to do to set up a browser page. Okay, so we have basically a helper function that's going to let us navigate through our application and also take a screenshot of that page as we've navigated. So this is a function that takes in our page object that we created from our setup function. and then whatever route that we want to navigate to. So this is a straightforward example. This is directly navigating to a page. We're not interacting with the page quite yet. We're just going to be able to kind of like navigate directly through the URL for different pages. So we take that route. You don't have to specify a route for your index view, so we give it kind of a default file name. And then we're going to save our screenshot based on the route name so that we can easily identify it as a person looking at these images later. So right now, this is hard-coded for our application that's running on localhost. It takes in the route. You can call page.screenshot, tell it the path where you want to save it, and then we have a compare screenshot function that we can then call to retrieve our additional information on it. One thing to note is that there are a lot of options on how your screenshot is taken. So you can kind of control if you only want to take a screenshot of the page that's actually shown within the browser viewport. You can take a screenshot of the whole page, a bunch of different stuff there that's worth kind of like looking into the docs and exactly how you want to set this stuff up. Okay. So we have a helper function that's going to process our screenshot. And so this is just some JavaScript that is retrieving the images off of our file system. So this is just a way to basically like run a couple of parallel tasks and wait for them to come back. So saying like, here are two images, read them, and we can continue after they have both returned. And then we destructure them off of that object. So we read the two files out. We now have our image 1 and image 2. So compare is a built-in function to resemble JS. This is the programmatic API for something that I'll also show you in a second. But basically it takes in our two images, some optional data, and that's just like a configuration file. And then basically waits for this information to come back, gives us back our image output, and then also gives us back something called our mismatch percentage. So our goal is for a mismatch percentage to be, this is actually wrong, it's right in the code, I promise. We actually want our mismatch percentage to be 0 because we want there to not be any difference between our two screenshots. And in the case that there is a difference between our two screenshots, that's where a human kind of has to come in and say like, yes, I approve this change, or no, I don't. Okay. So this is two separate screenshots of the React application that you could have running on your machine locally. They have very slightly differing things. You can kind of see that the images are slightly different sizes. In the image on the right, the dinosaur images are slightly larger than the other one. And so when we run this through the visual diff, this is actually what we get. So this would give us back a mismatch percentage of greater than 0, and it actually goes through and kind of highlights and shows us like exactly what pieces of the page have changed, so you can see where your differences are. And so kind of wrapping up this whole flow, you run through your tests, you take screenshots of all of your pages, you can then compare the current screenshots that you've taken against your golden images, and then if you're getting any sort of mismatch percentage, you can alert the user and say, hey, like this test failed, these screenshots don't match, you should go check out this specific file to see if those are changes that you want to approve or disapprove. And then at that point you can say, yes, this is fine, generate my new golden screenshots and keep everything up to date. Or no, this change was not intentional, like there's something actually wrong, we need to go back and fix this before we can regenerate our screenshots. And so some really good examples of this are, say for example, you have like a specific button on your login page and the decision is like, we're gonna make the login button purple. But you accidentally change all the buttons to purple. So this is something that would be able to catch that, and then you could say, okay, like we want to only change the button on the login screen, regenerate that golden screenshot, but the other ones are broken, we need to fix those. Okay. So now we're gonna switch over to a little bit of code. So I do want to just kind of go through and point out the different things that are in this boilerplate at this point. So I have opened up the code directory and the visual regression testing directory. I am on the visual init commit. And let's see what we've got. So we have our source directory. All of our tests live in this, ironically, dunder tests directory, which should feel familiar to some of us. And then we have our directory where we store diffs. There are probably already some, there are some directories in here from like future steps that we're going to go through. But basically we have our index page, which is rendering sort of oddly in here. We have our golden screenshots. And then we have, oh wait, sorry. This is our diffs, that's why it looks funny. And then we have like our 2 original golden screenshots. And so currently I haven't made any changes to this application. So my index and my golden index and my screenshot index are identical right now. All right, give me 1 second to pull up what I need. Okay. So basically everything that we went through in the slides has already been implemented in this code. So all of our helpers are living in this helpers file. We have these diff options, which are super interesting. So I'm actually going to show you, Resemble.js has a web interface where you can go in and kind of test different things. And so this was an example of, I made some very small changes just live on the PyCon site, where I think I made the images on this slightly smaller and I made the border slightly larger. So you can see like these really interesting specific like changes that happened in this area and how things were shifted. But what I really like about using the web interface is that it lets you play with the different settings for Resemble.js. So I'm setting a bunch of our like diff options, and so you can control like the error types, how transparent it is, the different colors. One of the things that Resemble.js does really well is it handles anti-aliasing, which basically means that it can ignore differences in how fonts render depending on the machine. That was one of like the big problems with screenshot testing, is that you could compare screenshots from different operating systems and the fonts would render differently, and it would cause these like false positives for saying that there was a difference when there wasn't really actually a difference. It was just anti-aliasing of fonts. So yeah, this is really, really cool, especially if you want to like see like different things that you can kind of like change and like rerun it. Shows you the difference, that kind of stuff. Okay. So what else do we have in here? So we've got Puppeteer. We're using compare images from Resemble.js. We have our take screenshot, which takes in the route. I think this is a little bit different from the slides, so I'm glad I'm going through this. But take screenshot gives you the directory where you want to put it. This allows us to dynamically generate either golden screenshots or like live test run screenshots and put them in different places. Again, this is hard-coded, so maybe not what you would actually want to do in a production version of this. Then we can go through, take all of our screenshots, generate golden screenshots, and process them. So hopefully all this makes sense. Let's take a look at our test file. Okay, so in here, again, we're using just an enzyme, so we're grabbing all of that stuff, grabbing configuration. So we do have like a place where we're storing the paths for our directories, just so that we can kind of reuse those throughout. Very little test boilerplate, which is nice. A lot of this stuff does kind of just work out of the box. And then again, running this kind of like before all setup, making sure that our golden directories exist and that our test directories and diff directories exist. And then this is really like where the meat of it is, where we're running a test on our index page. So we are going through setting our viewport. Default viewport right now is 800 by 600. And then we want to make sure that our index page is rendering properly. So this take and compare screenshot is like a really excellent helper for being able to go through, take the screenshot, generate the difference, make sure that everything is like asserting properly, and then you just return the true or false value out of that helper. All right. Let's see. So I think one of the first things that I wanted to go through and do was show one of those strengths of using visual screenshot testing is that you can test a bunch of different browser sizes, as well as kind of emulate different devices. So let's set up in our config, where we also are storing diff options and directory information. I'm also going to set up a few screen sizes. So let's say we want to test for both desktop and mobile. And we want to maybe have a list of different viewport sizes that we want to test. So I'm cheating and I have a list of a couple of the common ones. So 1024 by 768 and 1366 by 768. And then we'll also test a couple of mobile ones. I think these are all like iPhone sizes. So this is going to be a little bit more, I can't think of the word I want to use. It's not super realistic because there are a lot of other things that go into how a page is going to render. Whether that is the like user agent of a phone is going to cause pages to render differently. Devices will have maybe certain pixel ratios that cause pages to render a little bit differently. And so these are all really interesting things that you can actually use Puppeteer to also emulate those different changes. Let's see. I'm actually going to copy the rest of the mobile ones. Okay, so now we've set up our screenshot sizes. We need to do a couple of things here, right? So in our helpers, we're going to need to be able to take in different screen sizes. I'm actually really curious why I was doing this. I think I was having issues with importing this, so I'm going to move this over so that I'm not debugging imports uselessly right now. So you can pretend that that import would have worked. I'm going to just put this here so that we don't waste time on that. Okay, so now we have our screenshot sizes. So what else are we going to need to do? We are going to want to update our take screenshot so that we can also take into account our screen size. And so we're going to do a couple of things. We want to place these into a separate directory so that we have everything in kind of one place depending on the screen size. So let's say we need to get screen size and our screenshot size. Okay, so if we have screenshot and screenshot size, let's say we want to, instead of just placing this into a file name, we want to actually nest this into our directory. So this is like a string template. So anything that's inside of the $curly brace is going to get interpolated as a variable. So I can also say here, let's take in our screen size and group all of that together. And then I'm actually also going to add in our screenshot size. And so let me be a little bit more specific because I think these are a little confusing. My intention for these variables is for screenshot size to be the actual dimensions of the page that we're taking. And then screen size is just like mobile versus desktop. So at the end of this, we're going to have a mobile directory with all of our mobile screenshots separated by like the screenshot size, like the actual dimensions of it, and then same for desktop. So, okay, so this is where types comes in handy. So screen size I intend to be a string, and screenshot size will be an array. So let's see, I'm actually going to copy this as well just for the sake of time. So this is going to get nested, screenshot size nested into the array. So this is grabbing the first value by the second value, and I'm missing the ending curly brace, and these are spelled differently. Okay, cool. So now I have this directory that I'm going to kind of like save everything into really neatly. The next thing that I'm going to do is, so even once I have my page object, you can go through and change your viewport at any time. So also in this function, I'm going to say page.setViewport, and I'm going to set, again, I'm going to copy and paste this. I'm going to set my width and my height to the values that I'm passing in. Let's see. And apparently my linter is just going to freak out about weird things. Okay. So I think this take screenshot function should be good to go at this point. The next thing that we'll want to do is we can make our lives really easy. So basically for each like route that we want to take screenshots for, we can automatically take them for every single like viewport size that we wanted to define. So let's see. Let's actually look at our test file. So when we run take and compare screenshot, we're going to want to run this for every page. So in take and compare screenshots, we're going to tell it to take the screenshot and then process it. Let's see. I actually think we might want to do this at a different spot. If we do it in take screenshot, we can make sure that we're setting the viewport. Let's see. I think I'm confusing myself. One second. So take and compare screenshot. Take and compare screenshot is going to call take screenshot. Oh, and then we're going to also need to generate our golden screenshots. That's where I was getting lost. Okay. So let's take care of that first, actually, and make sure that all that gets generated properly. So generate golden screenshot, we'll call take screenshot directly. And let's see. If we now have our screen sizes object in here, let's see. I'm going to go ahead and do this here. So we can basically iterate over all of our screen sizes. And we can say for each screen size, these are fancy JavaScript arrow functions. So this is going to take this in as an argument, and then I can basically say, I'm going to copy this as well. So at this point, we just want to make sure that all these directories exist that we have just created. So just creating these like base screen size for mobile and desktop. Okay, so now that we have that done, we can now generate all of our desired screen sizes. So again, this is generating all of our golden screenshots. We just made sure that all of the directories existed. Now instead of just taking screenshots for this exact viewport, we're going to want to do the same thing and kind of iterate over all of the screenshots. So I'm also, for the sake of time, going to copy this as well. Or maybe I'm not, because it doesn't like me. One second. Okay. So now instead of doing this directly, this is going to be another iteration. So for every single screen size, we want to go over every single screenshot type and make sure that we are now generating for each of those. So we create our screenshot size based on the screenshot type. If you remember what that object looked like, this is a nested, an array of arrays, basically, is what we're kind of indexing into here. And then basically what we're doing is creating a list of all of the screenshot actions that we need to take, and then we can kind of run all of these in parallel and make sure that they all complete and then return. So we can actually replace this here and say, like, once all of our screenshot actions return, then we can close our browser and clean everything up. So I think at this point we've done everything for generating our golden screenshots. Let's just see, yeah. So I did something funny with set viewport. Let's see. So take screenshot, call set viewport, and this calls set viewport. So I actually think this is not happy about calling set viewport here. I'm going to try, for the sake of time, I'm going to try just creating a new page here. I think it's not happy about that. Let's see if this works. So I'm also going to take in our browser here, creating a new page, and then when we call take screenshot, yeah, we now have a browser. Okay, now this should work, hopefully. Hey. Huh. Well, that's unexpected. Something has to go wrong, right? Like, interesting. I'm curious to see if it generated any of them. I know this is really small. I'll fix it in a second. Interesting. So something actually did go right. I don't think I can make, I don't really know how to make this too much bigger, but I can temporarily zoom in for you. So something's definitely going right. We have our desktop and our mobile directories. We now have a bunch of screenshots that are taken, and we have the different viewport sizes and the file names for desktop and mobile. So something is going well. Okay, so at this point, I do know I'm starting to get tighter and tighter on time. So I am going to cheat a little bit and check out to these different commits so that I want to make sure that you all can see all of this kind of working and not just watch me kind of like struggle through live coding in front of you. Okay, so, and I'll actually show you what I'm doing too. So this is kind of what I mentioned earlier for like one of the possibilities of how you can use this content. So I'm going to go through, I want to look at the commits that I have. And so I think I was trying to get screenshots for various desktop sizes working. I do want to show you for different devices specifically. So if I go through and show you this diff, we're basically now going to like take into account different device types as well as the actual sizes. And so this is some really cool stuff that you can do is Puppeteer will actually have built-in like emulators for different devices. So instead of having to go through and like figure out the exact like pixel ratios and like dimensions of devices and trying to do that all yourself, you can just tell it like, I want to emulate an iPhone 6, an iPhone 10, a Galaxy S3, 3, 5. I'm an iPhone person. Whatever the device types are, you can just like give it a string, and it will actually kind of just render it based on that. So I am going to cheat and show you this working so that you can see the screenshots. So I'm going to go through and generate my golden screenshots real quick, and then I'm going to go through and just run the test and make sure that all of that is working. Maybe. Okay, cool. So we can see here, this is going to go through and print out all of our information. And I'll show you exactly how this is doing it too. So this is a little bit of like kind of generating these different devices that you're seeing here. So not all of these are hard-coded. We're actually iterating over this and creating test cases for them automatically. And then if we go through and look at our files that we now have, you can see that we have desktop. These didn't get regenerated. These are just left over from before. And then we have our mobile devices. So you can see this page looks really wonky on an iPhone 6, but at least we can kind of like see this here now and have a really good idea of what needs to be fixed for different devices. Okay, so let me see if I can pull up exactly where this is doing this stuff. So now if we go back and look at our tests, let's see. So in our tests, that's all of the setup. Cool. So here's where we're actually like generating tests for different screen sizes. So really similar to how we started off before. We're just going to iterate over the like setup config file for all the screen sizes that we want to test. And then we can generate these tests using describe. And then I still really like using the string template where you can interpolate in directly in the function parameter and create all of this. Yeah, and then it's taking the screenshot type, the screenshot size, and is able to figure all of that out. And then we do have specifically, we didn't add a configuration for, we didn't add a configuration directly for the device types. This was just an example with an iPhone. But you can also go through and add like a devices parameter and do the same thing here. Okay, let me see if there is something else that I wanted to specifically walk through on here. Yeah, so a lot of this is going to be kind of walking through and just doing some sort of best practices. So moving that base URL into a configuration variable, creating all of our different like routes and whatnot based on that. Yeah, I think that's most of it that I had in this repository currently. Some other options for how you can actually create all this stuff. So I'm curious to see, let's just go ahead and check out the end product. Okay. So now we can go through and generate, hopefully all of this works. Yeah. Somehow I'm not surprised. So this probably, JavaScript does get kind of tricky and kind of likes to complain about promises and different things. So there's probably just something that I didn't have caught that was not getting returned properly. Okay. So this is just not going to like me much at all. But this actually, so this leads me into the next section that I really wanted to dive in and kind of talk through. So at this point, you can kind of see that there are ways to set up this foundation for visual testing, where you can go through and set up different devices, different pages that you can view. A lot of this, once you get the base foundation set, is really easy to automate, and just kind of like as you add new pages, you already have this foundation for all of your different screen sizes and whatnot. So again, this is probably a lot of boilerplate and a lot of things to understand, but it's kind of like a set it and forget it kind of thing, and then you can build on top of it. So next things that I wanted to kind of talk through is actually navigating to pages. So what we were doing in this example was going directly to URLs, which is really, really great. Like if that's your goal for screenshot testing, is making sure that your site looks good and is scaling across devices, you're probably going to be set with just kind of using the URLs and navigating to it directly. But there's a lot of power in what you can do with actually navigating through your page as a user would. And so you can use HTML, like standard CSS selectors. If you haven't seen those before, you can target HTML tags directly. You can target classes directly. You can target IDs. There's a whole list. I really like the list that HTML Dog has. That's a great resource. Check it out if you need it. But basically, you can use these selectors to tell Puppeteer to interact with the page in different ways. And so you can do things like clicking on a button, focusing on an input field, filling out an input field, submitting a form, pressing enter. There's actually like a really, really, really huge list of all the things that you can do with Puppeteer. So I know this is probably kind of small, but I want to show you, where's the list of all of them? Yeah, so this is the list of all the API interactions that you have. So some other cool things that you can do is like tap into like these dev tools that I was talking about. You actually have access to all of those. There's a lot of ways to tap into like your render cycles for animations. That's all there. And then there's like just a bunch of different ways to navigate throughout your application. So especially when you're dealing with SPAs, making sure that your back button actually works the way that your like in-app back button works is super important. I think going through and using this, I think that they have support for like testing accessibility, which is also really important and usually something that your developers are probably not thinking about as frequently while they're building it. So making sure that you have tests for things like accessibility can be really important to make sure that that remains like a priority and doesn't break in your application. So yeah, this is like a really, really, really great resource. There's so much stuff that you can do with this. They just make it so easy that you can't not. Okay, so I'm going to talk a little bit about some best practices. One of the things that you'll often see are really, really long selectors. And so it's really interesting to kind of compare. If you've worked with CSS, you've probably learned a bit about some CSS best practices. So the selectors are the same, but the best practices are not. In both worlds, long selectors are typically not great. As you can see, this didn't like even fit. And so the more nested your selectors are, the more prone to breakage they are. And so if you, for example, figured out that you didn't need this, this div that was enclosing your container and you just took it out, you would probably have a bunch of tests that would break because your selector was relying on this kind of useless div. The other interesting thing is that a sort of best practice for CSS is to try to not use like IDs as selectors as much as possible, because that typically makes it so that you're only targeting like a single element on a page, which if that's the intention is great, but if you're trying to like style all of your buttons or something like that, that's typically not a good practice. But IDs are really, really ideal with testing. And a lot of frameworks actually have it built in, so you can specify a test ID specifically that you can target. So you can get really clever with how your team wants to kind of set up your own best practices. You can add your own data attributes to tags. So like the same way that an input field has like a type or a name, you can set up your own kind of naming convention for an attribute that you use for all of your tests. And then even if you wanted to, you could kind of strip all of those out before you push them into production so that all of your IDs are kept private and internal for your company. So IDs are really ideal. It especially always follow best practices where like there's a single element on a page that has a single ID. Having multiple elements with IDs is not necessarily ideal. I wanted to do a selectors live code, but I don't think that it's going to work. But I will pose it to you all as a potential exercise. My intention was that I wanted to go through and basically like write a test for like logging into the PyCon website. And so it would be a really interesting, if you want to use some of the time today to go through that, I think that would be cool. I was basically going to go through and test going to the home page, clicking the login page, and then submitting false information or like invalid credentials that would cause an error on the page. And so taking this kind of like foundation that's laid and figuring out how you can kind of navigate through, I think would be a good exercise to kind of build on this. So, okay, so I wanted to talk a little bit more about these like best practices and what you should expect. So some really great places to start are from user stories. Again, this is really, really user-centric, so focusing on what your user is going to see and like looking at your user stories is going to be the best blueprint for you to get started. But it's possible that you don't have user stories or that your user stories are out of date, etc. But again, they could be a good place to start. The most important parts, I think, are the critical business logic, and also the parts that are kind of set it and forget it. So one thing that you don't want breaking is your login page. That would be kind of a crucial piece that would break. Also probably something that you set up in the beginning of a project and don't really touch a lot. So those kind of set it and forget it ones are ones that you want to make sure have solid tests that you don't forget about. And also a good way to do it is just a sitemap. You can go through and make sure that all your pages are rendering right. Again, those pages that probably get forgotten sometimes, if you have an about page or a static page that nobody's really like working on, a lot of times you can have like inadvertent style changes or whatnot that make those pages render incorrectly. Oh, I don't know why that's on. 1 second. Yes, I don't know why this is rendering really loudly. My notes got really torn into this. So I wanted to talk about some next steps. So I mentioned snapshots earlier. There's a service called Percy that does a really interesting kind of combination of snapshot testing and screenshot testing. Where they actually have custom rendering agents that will take your snapshots and then re-render them into like an in-browser view and let you approve and deny your changes in their website, which is really, really helpful, especially if you don't want to go through and set up all of this kind of like from scratch. I'm also totally down to talk about like how to roll your own. I didn't want to get too vendored in my talk specifically, but I'm a huge fan of AWS. They have a lot of code pipeline tools that I've used. If you're interested in talking about how you can roll all of this into like a fully featured CI service, I'm here to talk about that. I think that was everything that's rendering there. So at this point, I am hoping that all of you can kind of dive in. If you want to have discussions amongst yourselves, if you want to come talk to me, we have about 20 minutes left of our official time. Yeah, I think that's it. Does anybody have any questions that they want to pose kind of to everyone? Uh-oh. Oh, okay. Yes, that is one thing that I wanted to talk about. It is totally possible to do all of this with Python. Like Aaron mentioned, there is a library for this that you can do all of this in Python. You can still do all of like the rendering and whatnot I'm not sure if there is a good wrapper around resemble.js, but I know that there are really advanced image processing libraries for Python that you could kind of roll your own on this. I forget the technical term, but there's like it's like some sort of like, the image merging has like a specific name for it. I can't think of it. But all this stuff you can do in Python if you really wanted to. It's just going to take a little bit more of like piecing some parts together. But yeah. Awesome. All right. I leave you to yourselves. I'm here if you need me.